Okay, so welcome back to Mr. Chappell's math class here on YouTube. Today we're going to look at the six proofs that I gave you as part of your preparation for your quiz. All right, I will have them in the presentation as on your worksheet, so just make sure you have that worksheet handy. All right, so let's take a look at the first one, number 26. Let me create my statements and reasons columns. Okay, and let's talk about this proof. In this proof, it says that segment PQ bisects angle SPT. And we also know that segment SP is congruent to segment TP. That's all given to us. So let's see what that given information will do. Well, on my picture, if PQ is congruent to if PQ bisects angle SPT. So here's angle SPT. PQ bisects it. We know those two angles are congruent because of an angle bisector. We know that. Side SPT, or segment SP, is congruent to segment TP. That's this side and this side. We know that. Okay? This is the pair of sides. So towards our proof, we have one pair of sides. Well, let's say what we can say based off of this first statement. Segment PQ bisects angle SPT. And again, understand the goal is to prove that the triangles are congruent. We want to prove SPQ is congruent to TPQ. So, if PQ bisects angle SPT, then we should know that angle, now these two angles have to be the ones at angle P, right? SPT, it's these two angles right here. So that would be SPQ, angle SPQ. That is congruent to angle TPQ. And that's because it's an angle bisector. Definition of an angle bisector. And there is a pair of angles. There is a pair of angles. Okay, so now we have a pair of sides. We have a pair of angles. Now let's look at the picture again and see that they touch. They share that side. They share PQ. PQ is congruent to itself. It's the reflexive property. And there's another pair of sides. So if we look at our picture, side, angle, side. Two sides and the angle between are congruent in both triangles. Therefore, we can say that triangle SPQ is congruent to triangle TPQ, and it's by side, angle, side. And there's the first proof. Okay, here is the second proof we have going, number 27. Sorry. So again, let me create my statements and reasons. Alright, so the first is always the given. We have segment EF congruent to segment JH. And we have segment EF is parallel to segment JH. That's given to us. So I'll mark that on my picture. Segment EF is congruent to segment JH, and segment EF is parallel to segment JH. So what I have already, if I want to prove these triangles congruent, I already have a pair of sides. So now we got to work on either getting more sides or more angles. Okay, we have parallel lines. We have parallel lines. This line and this line are parallel. Let's start with one transversal. Let's start with EJ. Okay, there's a transversal. EJ is a transversal. Alternate interior angles are congruent. Angle E is congruent to angle J. Now in yellow, I'm going to do the same thing. Not yellow, let's do blue. Parallel line, other transversal, alternate interior angles. Angle F congruent to angle H. Oh, not a different step. I'm sorry, not a different step, right? Same step, same reason. Same reason. It's because they're alternate interior angles. If lines are parallel, alternate interior angles are congruent. Pair of angles. What do we have? We have angle, side angle, angle, side angle. These two triangles are congruent. By angle, side angle. And there's that proof. Parallel lines, think of alternate interior angles. Okay, here is the next proof we got going. I'll create my statements and my reasons columns. Let's put in here that segment AR is perpendicular to segment TG, and that AG is congruent to AT. That's all given to us. So what does that mean in our picture? Well, if AR is perpendicular to TG, we know we have two right angles. We also know that AG is congruent to AT. Now, if we have right angles, then we can potentially use the HL congruence theorem. Look at AG and AT. What are they? AG and AT are the hypotenuse of each triangle. So we have the hypotenuse. Let's see if we can get a leg. Okay? Now, first thing though, the lines are perpendicular, but we didn't say that we have right angles. So that's the first thing we need to do. So, angle ARG and angle, so ARG and angle ART, angle ART, are right angles. And that is, of course, because the lines are perpendicular. Definition of perpendicular lines. Remember that upside down T means perpendicular. So there's the fact that we have right triangles, okay? Right angle, they're a triangle, right triangle. So now, let's look at the picture of legs. So the corresponding legs would be GR and TR, or AR and AR. There you go. Reflexive properties say that AR is congruent to AR. AR is congruent to AR, and that is, of course, the reflexive property. And there is your precious leg. You have the hypotenuse, you have the leg. That means that these two right triangles, triangle AGR and triangle ATR, are congruent. And it's by HL, hypotenuse leg congruence. So there's that HL theorem. Okay, so I'm going to stop here for this video, give you a second to take a break, and then I'll create the second video here in a minute. Alright, keep watching.